Wonderful. I did make it to the movies this weekend. I saw Red One. I've been so excited about that when it came out this week. A new Christmas classic for me. I'm gonna have to watch that one every year now. So Santa Claus is kidnapped. Got Dwayne the Rock Johnson as the security chief, and I love it. It was. I enjoyed it a lot. It was good. There's a lot of movies I want to see right now. So I'm gonna spend a lot of Thanksgiving going to the movies. I think next week, like Bonhoeffer comes out, and Wicked comes out, and Gladiator comes out. All these movies are out. A lot of good stuff out there. I'm not got enough time to see movies, I don't think. How we doing? We got most of us here already. All right, that's good. We're gonna learn about a better way to do graphics this week. So let's go ahead and get started here, just because we've only got so much time. All right, let's go to our grade screen as usual. Best place to start your day, just so you can see what the what. Let's see. Last week we had our introduction to Turtle Graphics, which is our 5-question quiz. This week we've got 4 loops, and this is a program we'll be writing. And look, we have 2 more assignments, and then the semester finals. So there's not a whole lot left. But let's look at 3.02. 4 loops. So this is a type of loop. This will help a lot in your graphics, being able to use loops. And we'll look at that today. Lather, rinse, repeat. Doing repetitive tasks might seem repetitive, but in reality, they make life easier. Like bathing in a regular pattern ensures an odor-free self. Right? Pedaling a bicycle over and over propels you forward. Likewise, in programming, the ability to repeat lines of code that you're going to use again saves time and makes for less work on your part. So that's what loops are going to do. Loops will repeat lines of code over and over until you tell it to stop. So that's going to be very, very useful. So how do you conquer a repetitive task in programming? It's simple. You create a loop, and a loop is program statements that can cause a segment of code to be repeated until some terminating condition is met. To make a loop, you need 2 things. You need something that you need to repeat and something that tells the program when to stop repeating it. For example, you understand the code needed to draw a line using Turtle Graphics, but what about a square? Well, there's 2 ways to do that. Let's look at these examples and see which one would you rather write, right? So without loops, if we want to make a square, and here's the output. Look, the output is exactly the same on both of them. Import turtle. That's the first one, both of those. Define main. We have our define main, of course, to start our main loop. So on the left, we got Leo equals turtle.turtle. And we tell Leo to go forward 100, turn left 90 degrees, go forward 100, turn left 90 degrees, go forward 100, turn left 90 degrees, go forward 100, turn left 90 degrees. So what you do, he starts there, goes 100, turns 90 degrees, goes 100, turns 90 degrees, goes 100, turns 90 degrees, 190 degrees. And then we ended our main function. Over here, we still named our turtle Leo. Leo equals turtle.turtle. But here's this loop that works 4 side in range 4. This is a for loop. You're telling Python that for a range of 4 iterations, repeat this 4 times, you'd like to go and do all the following code 4 times. So here's what's inside the loop. Notice it's indented. The loop is over here, but what's inside the loop is indented. And it says, Leo, go forward 100 and turn left 90. And it's going to repeat that 4 times because of the loop it's in. And it puts the exact same thing as the code on the left. So you can see where having loops is going to save us a lot of time because you don't have to keep writing the same code over and over and over and over again. Let's look at page 3. So imagine writing several hundred lines of the same code, right? Programming often requires us to repeat code because we do a lot of the same things sometimes if you write a program. But to avoid having to copy and paste a million times, we can use loops. Not only can it save you time, they can also cut down on errors because you're not writing as much code. The less code we write, the less errors we should encounter, right? In the example for drawing a square on the previous page, they used a for loop. So to use a for loop, we give Python our action, like draw a line and turn left is what they did. And rather than write that over and over, we say repeat this action, but stop after the 4th time. So let's look at an example of an active example that we can play with here. Read the code, try to predict the output. So for loops, import turtle, define main. All right, so that's just our standard define main statement. And now we have a turtle we're naming Tilly. Tilly equals turtle.turtle. We're telling Tilly color deep pink. Said, okay, print side 0. So this is actually going to print the words side 0. And then Tilly's going to move forward 100 and turn left 90. And then we're going to print the word side 1. And she's going to move forward 100 and move left 90. And then we're going to print side 2, move forward 100, left 90. And so this is basically a lot like the program we just looked at. Let's run it and see. Side 0, side 1, side 2, side 3. See how it listed each side as it drew it. Let's run that again. Side 0, side 1, side 2, side 3. Okay, so that's drawing a square, actually using the output to print what's going on in the graphic square. Let's look at the next one. Oh, it says, what if you wanted to draw a decagon, a 10-sided polynomial? Well, we'd have to do this 10 times. Print side 3, side 4, side 8, side 9, and side 10. Now let's look here. Another example. Define main, Tilly, turtle.turtle, deep pink. Now we just said for side in range 4. Now this looks really cool. So side is the variable we've declared that it's counting with. It's counting the side. So now we're saying print side in quotes, literally print this word to the screen with a space after it. And we want it to print what loop number it's on. For side in range 4, print what loop you're on. And then do that loop, forward 100, left 90. Let's run this. Now notice it looks a little different, side 0, because remember, Python starts counting at 0, not 1. 0. So it says side 0, side 1, side 2, side 3. It still drew that. See, it's a lot shorter, but it still produces the same result. We even have the same output over here, except for it starts counting 0, 1, 2, 3, 4. Now, if we want it to print, let's try this. Let's see if we can put +1 to where we can count 1, 2, 3, 4. Let's see if that works. 1, 2, 3, 4. Yeah, we know it counts from 0 to 3 and then stops when it gets to 4. But if I want it to print 1, 2, 3, 4, I just added 1 to whatever loop number it's on, because I know it starts counting at 0. I like start counting at 1. So we could change that and make that work. But still, it does the same thing in making this square with just 4 lines of code, including printing out which side it's making. Let's look at the next slide. Okay, slide 3. Tilly.turtle, royal blue this time. 4 side in range 4, print. So it looks like the exact same program. Yep, 0, 1, 2, except we're using a royal blue this time. So let's explore some common errors with for loops. Try deleting keywords and symbols such as the in, range 4, and the colon. Or try removing the indentation. Let's see. So if we didn't have the word in, 4 side range 4, what would it do? Bad input on line 10. So we got to have in. If we didn't have 4, if we just put 4 side in range, what happens? Oh, range takes at least 1 argument, and there's 0 given on line 10. It says you have to have a number. So if I put the number 2, we only get 2 loops, and it stops after 2 sides. If I put 6, it'll actually draw over itself. 1, 2, 3, 4, 5, 6. It just drew the same lines twice. Go back to our 4. Make sure that works. What if we did not indent in the loop? Bad input on line 11. See, just like we have to indent as part of our main function, If we have a loop, everything inside the loop has to be indented for it to understand the loop. So make sure when you use a loop, you indent everything that's part of your loop, just like we indent everything that's part of our main function. We have double indent for the loop. Run. Okay, that works again. If we didn't have the colon afterwards, what if you just wrote 4 side in range 4? That's going to give an error. You got to have that colon. So make sure when you're writing your program, you go back and look at this in the lesson to say, okay, how do I write a for loop again? Got to have the number, got to have the colon, got to have 4 in range. Side could be whatever you want to call it. It doesn't have to say side. It could just be for X. And then we'd say X. Yep. There we go. For X in range 4. That means this is a loop. I'm counting it using X. Run program. See, it's fine with that. Whatever we want to name that loop. It has to have a variable to use to count with. All right, let's go forward. It says, read the code, try to predict the output, run program. Change the value of the angle from 90 to 95 and modify it to 40 times. So let's see. What do we have so far? We have Michelangelo, the turtle. He's going to grab an orange pin. The length of the side is 75. The angle is 90. And they're using count this time. That's fine. 4 count in range. And he's going to move forward whatever the length of the side is and change at a 90-degree angle currently. So let's run this. So he makes a nice square. Now it says, let's change the value from 90 to 95. And let's repeat it 40 times instead of 4. Okay, so we did the recommended changes. Let's see what it looks like now. Look at there, repeating 40 times. Now we got this really cool little artistic design. Nice. So the for loops made that real easy. We didn't have to repeat this 40 times. We just put it in a loop. Now I want to look at something real quick. We go to our API that gives us all the commands we can use. Turtle graphics. One of the ones I want to look at is the speed, because I want to say, let's make our turtle move faster. I think these are in alphabetical order. Left, pin down, pin size, pin up, right angle, set position, shape, show turtle, speed value. So you do Terry.speed of 8 or whatever speed we want. Okay. So I'm going to use that code. And let's change Michelangelo's speed. I'm going to put it up here before the loop because it doesn't need to set it in the loop all the time. But we need to change it from Terry to Michelangelo. And let's take a speed of, I don't know what's fast. Let's see what 25 does. 25 is pretty fast. So if I want to make that even faster and do like 400 loops, now it's doing 400 loops. And he's moving really fast at a speed of 50. Boy, that's something. What if we change the angle to 85? Okay. 50. Change it to 50. Oh, he's got a lot bigger. He's off my page, actually. I'll make the side smaller. There we go. Yeah, it's just filling things in. But yeah, you can play with that. You can set the speed to go faster, loop it however many times you want to loop it. All kinds of good stuff like that. 100 loops. All right, let's look at slide 5. Read the code. Select run, try to predict the output. Define main. Leo, the turtle. Blue. Oh, here they're using the speed. They put the speed in this time. Doing side length of 10 and a 90-degree angle 60 times. But look, when he moves forward, we want to go the length of the side, which is 10, plus whatever the count is. That's the loop. Like it's going to start at 0, then it's going to be 1, 2, 3, all the way up to 60. And we're going to take the count times 2. So whatever that is, we're going to add that to the side length. So every side is getting longer exponentially because it's going to be the count times 2. And it's going to turn 90 degrees every time. So let's run this for 60 loops. Run program. Oh, look, that's what it's doing. Every time it's getting longer by 2. Because whatever the count is, it's multiplied by 2. So on the first loop, which is loop 0, it's just the length of 10. But then when it gets to loop 1, it's going to multiply it by 2. So it's going to add 2 to the 10. So it's going to be a length of 12, and then a length of 14, and then the length of 16, and a length of 18. So every time it's getting a little longer, we make this pretty cool little pyramid looking type shape, like we're in a drone looking down a pyramid or something. Cool things to do. Let's look at slide 6. Okay, we're going to, your turn, create a turtle and move it in a pattern or shape of your choosing. Maybe an octagon or star. Make any change you'd like to the existing code. So let's see what the existing code is. We've got Ty the turtle, forest green with a speed of 10. He's doing a side 10, angle 90 for 10 loops. Let's see. That's just square over and over and over and over. So let's do our side plus count. So every time it gets a little longer, let's do an angle of 45 degrees. Let's see how that works. First, we'll just do 10 loops. Now let's change it to 30 loops. Oh, that's kind of cool. Play with this however you want to do it. You have access to this. This is on page 3. Play with the different things you can change and see what kind of shape you can build. Let me make this 145 degrees. That'll be very different. Oh, that's a star, a growing star. Look at that. I'm going to do 130 loops. I'm going to triple the speed to 30. It's a rotating star. Kind of a cool pattern. So you can play around with it and get all kinds of crazy shapes using the for loop. All right, let's look at page 4. For loops and counting. One of the best things about the for loop is it gives you control over where the repetition starts and stops. In other words, it'll stop when you tell it to, but you have to actually tell it to. When coding a for loop to make a simple square, we gave the turtle a range to repeat his movement 4 times because we have 4 sides. We only need 4 loops. Well, look at this drawing they're making over here on the right. That's pretty fancy. The range can be more specific. By passing 3 values to the range, you can specify a start value. Look, we could make our range start with number 9, count to number 20, and go by 3s. So do 9, 12, 15, 18, and then it would stop. That would just be 4 loops. But maybe you want to use that loop number inside your loop for the side angle, for something like that. So when the loop begins, the counter variable n, right there, n, is assigned the start value of 9 because that's the first number we put in the parentheses. And after each iteration of the loop, the value increments by 3 because that's the number we put down there at the end. And it repeats if the value is less than the ending number. So the loop will have values of 9, 12, 15, 18. Then it'll be equal to 21, so it will stop because it's reached the ending number. Let's look at page 5. So as you've seen, programming large amounts of codes often involves using repetitive statements that would take an extremely long time to write if you weren't for these handy for loops. So loops are useful in a lot of situations, not just drawing. There may be other reasons you want to use a loop. From basic calculations in math to more complex stuff, for loops make it easier. So here's some practical ways to use some for loops here. So let's go look at our other guided activity. 4 loop ranges. Define main, print, I can count, and then we did a loop for in range. Start with the number 0, stop when you get to 10, and count by ones. Print whatever loop number we're on, string in, because that's what we're printing, Mississippi. Run. I can count 0 Mississippi, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, all the way going. Maybe that wasn't what I was looking for. Maybe we wanted to start with 1 Mississippi. So let's see. Let's change this to start counting at 1 and stop when you get to 11. Oh, see, now it counts 10 Mississippis. Because I changed it and told it to start counting at 1. And then when you get to 11, stop. So it didn't print 11. Notice it stopped at 10 because 11 is my stop value. When it gets to 11, it says, whoop, no more. If we wanted to count to 15, we'd say stop when you get to 16. Now it goes all the way to 15 Mississippis. Because remember, it will not do this loop. That's the stop value. It goes, oh, stop. Okay, I'll jump out of the loop and continue on with the program. All right, slide 2. Read the code, try to predict the output. Trevor the turtle, the royal blue pin at a speed of 10. He's got a range starting with number 5, stopping when it gets to 25 and going by ones. Print n equals. So that tells us which loop number we're on. The first one should be loop number 5. Then he goes forward 100 plus that 5 and turns left 90 degrees. Let's run that. Oh, there it is. It's printing all of our loop numbers. Oh, it made a nice frame, right? Nice big square frame. And it stopped at 24. 24 was the last number. Because 25 is our termination number. Oh, gets 25, it goes out of the loop, jumps down to the next line of code, which was just the end. So this means the loop's counting variable starts at 5 and goes on until it gets to 25. So what happens if you subtract the value of n from 100 in the forward function? Oh, well, let's instead of adding the value of n, let's subtract it. What do you expect will happen? Well, the side links should get shorter each time, right? Let's run it again. Oh, see, now it's getting smaller and smaller as it goes. Let's change that to 55. Let's make that loop bigger. See, we could keep that going until it filled in the whole space. What happens if you subtract the value of n from 100? That's what we did. Subtract it down. All right, slide 3. Oh, print the countdown. Now look, we're going backwards. We're counting by -1. So you could do that. You could start at 10, stop when you get at 0. It's going to print these 3 dots, and it's going to print whatever the count is, because that's the variable we used. And then after it jumps out of the loop, then it's going to print blast off. So it's doing a countdown. The countdown, and it printed 10, 9, 8, 7, all the way down to 1, and then hit blast off, because after it got out of the loop is when it prints that. Countdown. Love it. So yeah, you can count backwards if it works for whatever you're trying to do. You just give it a starting number, an ending number, and what it's counting by. In this case, it was counting by -1s. Import turtle, define main. Tate's our turtle. He's going to use a maroon pin at a speed of 10. And look, we're telling him to start in this position. Instead of starting at 0, 0, he's going to move left and up and start a little higher and to the left. For n in range from 25 to 0 by -1, going backwards. So he's going to go forward 150, and then he's going to turn left 180 minus, first time it'll be 180 minus 25. The second time 180 minus 24, 180 minus 23. So the line's going to be getting closer and closer to turning straight. Let's go. Oh, that's a pretty cool pattern too. Let's increase the range. Let's go from 50 to 0. It's going to get to the point where it actually just goes 180 degrees and then starts going the other way. Now it's yep, about 180 degrees. All right. Look at there. Pretty wild looking. If you guys aren't going to these guided activities and practicing with this, you're cheating yourself here, because this has already got a built program that you can just go change things and see how it works. See what happens when you change it. Slide 5. Read the code, try to predict the output. All right. Define main, for looping ranges, total print. I can count by 5s and add them up. Oh, so we're using a loop that starts at 0. It counts to 100. It stops when it gets to 101, right? And it goes by 5s. And it totals them as it goes. So it's going to add whatever loop number is to the total. So first it's going to add 0 to the total. Then it's going to add 5. Then it's going to add 10. Then it's going to add 15. And it's going to print each loop as it goes and then give the grand total after the loop. Notice that's after the loop. It's not indented. 0, 5, 10. There it is, all the way to 100. And it adds to be 1,050. If you're not sure, get your calculator and add those numbers up. But they total 1,050, which would be correct there. All right. Small twist to it right there. Went by 5s. And we totaled up each loop number. Okay, here's our last example program. Import turtle, define main. Taya the turtle. Speed of 10. Pick the pin up, move over to this position, and put the pin back down. All right, so we have two different things going on. For in and range, so here's one loop. We're using one loop. We're starting at 2 and going to 26. So 25 be our last loop. Counting by 1s. So this says use aqua, go forward 10 and turn right 15. And then grab a different pin, dark orchid, and make a circle of radius 5. And then go back and do it again, over and over and over again from 2 to 25. So let's run it, see what it looks like. Oh, look at that. As it's making this bigger circle, it's making a bunch of little circles as it goes. Because it's doing two different things. It does aqua, moves forward 10, right 15 degrees. So it's those are little straight lines, the aqua lines are. So let's change it to red. Maybe be a little easier to see those lines. Yeah, now you can see the red line. It's making the little red line. And it keeps going until it completes back to where it started with all these little circles. The turtle's spinning now. So it says, how that count changes can be controlled. In this program, by simply changing the counter to increase by 2, the size of the circle drawn changes by 2. The range of 2, it says 252. All right, let's see what happens when we change this to 50. It just repeats over itself because it only needed to go 25 to make the circle once. So what if we make it change by 3s? Let's make it change by 3s. It doesn't finish it because now it's not counting by 1. So instead of doing from 2 to 49, it's skipping 2, 5, 8, 11, and we don't have enough loops to finish. Making 150. Counting by 3s, now it should have enough loops to make it all the way around. Plus some. Oh, it says change the value passed to the circle function from 5 to 5 plus n's. Oh, so let's make the circle bigger as we go around. I'm going to go back to 2 to 26, counting by 1s. But this time the circle is going to get bigger every time because it's going to add the loop number to the radius of the circle. So it should get bigger and bigger. See that? The circles get bigger as it goes around because we're adding the loop number to the radius. I say, play with this however you want to. We could add the loop number to the distance it moves each time. So it's going to make a bigger circle. Look at that. Oh, it ends up off our screen up above. So if we set the position to, let's see, try -80. Let's see if we can see it then. Oh, now it started way down here. But it went off our screen on the bottom. But we can see the top again because we told it to start down lower at -80. Move it to the right some. Maybe we can see more of it. It does go off the bottom of the graphics screen, though. All right. Well, play around with that. Play around with that. Let's take a look at the template because we have an assignment for this. When you get to the assignment, it's just where you submit it. So let's look in our Google Classroom at the template for this week to see what's required. Do this week, use the template below. So if we look at the template, here's what your program needs to have. Decide on a repetitive pattern or outline of a shape, a house or whatever you want. Give your artwork a name. Print the name to the output. Using for loops and the turtle module, draw the outline of the shape of the repetitive pattern. Use at least one for loop that repeats 3 or more times. So you have to have a for loop in your graphics. You have to use a color other than black. You can use black, but you have to use another color at some point. Make sure you write the pseudocode. Make sure you use Python idle. Make sure you got your name, date, short description. Make sure you indent things properly or your loop's not going to work. And use meaningful variable names. So here's where someone drew a house. Someone drew just a nice big spiral using 2 different colors. House uses 2 different colors. Copy and paste. Paste your screenshot of your output. Let me see what your picture looks like. Copy your code. No screenshot. No screenshot of the code. And there's our problems right there. So I want to show you. I've played around with this. Let me open up an idle window. And I've got some code here. Let me copy my code. I'll paste my code in here. Look, mine's 143 lines because I had a lot of fun with it. I have a turtle named Donald. And look at all the different things I'm doing with it. I made it black first, speed of 400, pick the pin up, moving this position, put it down. I drew a house with this loop here, the roof of the house with crimson. I used a loop up here. Picked the pin up, moved him, put it back down, black. Did a door for my house, a wreath, using a loop with 12 for a circle. I keep moving the circle. Ground. So here, let me run the program, show what it does. Put a wreath on the door after I drew my house, made a tree out in the yard, the level of ground, chimney, some windows, and a sidewalk. Just having fun with the turtle graphics. Like I said, it took a lot of lines. And I had to go study that pin down, pin up thing, pin down, pin up. Because after I drew like the wreath, I wanted to move over here without it drawing a line from the wreath to the tree. You know, I didn't want to draw a line. Pick the pin up, move over here, put the pin down. And I had to play with where to put it at. Set position at -140, -60. I had to figure out where that is on the screen. So, because that's the tree trunk. So the tree trunk started over at -140, -160. I did a fill because I filled in the brown, but just having fun drawing something here. I'll clear it and run it one more time. So the tree was very similar to the wreath, just a bigger size. And mine prints Merry Christmas to all, little Christmas program. Putting the Christmas wreath on the door and all that kind of stuff. So you can play around. It takes a lot of code to make a real bigger picture like this. You don't have to do all of this. You have to draw one thing. You have to draw one thing, and you have to use a for loop to do it. For loops in the turtle module. You just have to draw one shape. If you want to draw more than one shape, that's fine. Like I say, I kind of went crazy with it. I was just having fun. I'm doing all kinds of crazy stuff with it. Just having a blast with it, because you're only limited by your imagination, right? So you can just figure out all the different commands. Go to that API, Turtle API, that Python API button, and see the different Turtle commands you can use. And you can have a lot of fun with this. So have some fun. As long as you got at least one for loop, more than one color, and you're using the Turtle graphics, make sure you print the name to the output. Like mine was just Merry Christmas Doll. That was the name of my art. So make sure you print something to the screen just to show what the name of that is. But write your pseudocode. It'll take some planning. You got to plan this. But I think you can have a lot of fun with it and enjoy it. If you get stuck, hey, oh, wait. This is not an A-Day. If you get stuck, you'll have to come see me Wednesday, because Friday is a B-Day. We won't be in class on Friday for the A-Day, folks. So anyways, any questions on this? Does it look like you can have some fun with it? Practice those four. Go to the lesson. Practice in those guided activities. If it looks confusing to you, go and see how those things work. Change the numbers in those loops and see what it does. Change what you can even change the total printout to do something different and put it in the loop and see how it works. So, all right, guys, if you have trouble, you can email me your programs. I'll help you figure it out. Say, hey, Mr. Bruck, I'm trying to do this. I'm getting this error. What's going on? If you can't figure it out, I'll be happy to look through it myself and see what I can figure out. So, all right, guys, have a great week. We'll see you Wednesday if you need to or want to be here. Otherwise, if I don't see you again, have a great Thanksgiving week, and we'll see you after that.